Hi everybody. This is a quick lesson in Intro to Matrices. So we're going to do 5 things that are all pretty simple, but we're going to roll through them quickly. So feel free to, pause the video because you have that power. So the first question is, what is a matrix? And the plural of matrix is matrices. So what a matrix is, it's an array of numbers. So here's an example of a matrix. 3, 1, 4. Okay, so we put big brackets around it. Here's another matrix. 1, 5, negative 7, x. Okay, just like anywhere else when we have a number, sometimes we can put in a variable. Here's another one. 3. Here's another one. 1, 2, 7. And one more. 2, 3, 8, z, 1, 5. Okay, so what you're asking is, why are we doing this? I hope. But let's repress that for a little bit. We need to define this new mathematical object, matrices, and then we can see how they're useful to us. Okay, so some things about matrices. We will sometimes discuss their dimensions to describe what they are. And the dimensions of a matrix are given in the number of rows by the number of columns. So rows go across, columns go down, like in a building. So this has 1 row and 3 columns. So this is a 1 by 3 matrix. This has 2 rows and 3 columns, so it's a 2 by 3 matrix. This one has 4 rows and 5 columns, so it's a 4 by 5 matrix. And this one has 4 rows by 2 columns. Okay? And popping back, we have this interesting one. This is a 1 by 1 matrix. This is a 1 by 3 matrix. This is a 3 by 1 matrix. Okay, so always rows first by columns, rows by columns. That's how we talk about them. Okay? Second thing is, when are matrices equal? Okay, and they are equal when they have the exact same dimensions, and then they have the exact same values in the exact same spaces. So for example, this first one, well, this is really different. So we have a 2 here and a negative 2 here. So they're not the same. Okay, these are not equal. Not equal. Okay, here we have 2 2s and 2 2s, but they're not the same dimension. So again, not equal. Here, let's check it out. We have 4 and 4, so that's right. And 2 and root 4, oh, tricky, tricky, right? That's a 2, so that's equal. 3 and 3 over 1, so that's equal. And negative 1 and negative 1, so that's equal. So these are equal, because every value is the same in every place. Okay? That's how we tell if matrices are equal. Now, you might say, what do we do with matrices? Well, let's do some things that we've never done before on things other than numbers. We're going to add them. Now, you may think you know how to do this, but you have to admit you don't, because you've never seen a matrix before. And so how would you know how to add them? You have a way you hope we add them, and you're hoping that it's easy, and it is. So in this case, when we add matrices, we add the corresponding places. So 1 plus negative 2, negative 1, 4 plus negative 4, 0, 5 plus 1, 6, 2 plus 0, 2. Okay? And that's how we add matrices. Which raises a question. I know what you're thinking. What if they're different sizes? So the question is, what if they're different sizes? Nice question, everybody. And the answer is, for example, for these, right, this is a 1 by 2 and a 2 by 1, and the answer is we can't add them. Okay, so that's a little bit unusual, because when we've seen addition before with numbers, we've never come across 2 numbers we couldn't add. But now we have matrices that we can't add. So if they're not the same dimensions, we can't add them. Subtraction works the same way. If we look at this, you can see how to do it. You subtract each corresponding place from the corresponding place. And all of these are doable. Okay, here again we have 3 by 3, so 9 numbers to subtract, and it would give us a 3 by 3. But here, because it's a 3 by 1 and a 1 by 3 and a 3 by 1, we can't add them. Okay, so can't do it. I don't know what that line was. Can't do it. Get rid of that line. Okay, can't add. Okay. Both of those look good. We could add those if we wanted to. Okay, now we have this weird thing, which again is new. This is called scalar multiplication. And it's a product of two different things. It's a product of a number and a matrix, which again is not something you've done before. We've always multiplied two numbers, but now we're multiplying a number times a matrix. And again, you don't know what to do because you've never seen this before. And someone's just going to say how to do it. And I'm going to tell you what that someone said when they decided that this was an operation. And it is as nice as you'd hope. We're going to take this number and sort of distribute it among all the numbers in here. So we're going to multiply each number in the matrix by the scalar. So negative 3 times 4, negative 12, negative 3 times 2, negative 6, negative 3 times 3, negative 9, and negative 3 times 2, negative 6. Okay? And so we've done something unusual. We've taken something from two different kinds of sets, one from the number set, one from the matrix set, and we've done an operation on them. So that's not something that you've seen before. All the group stuff that we did before was all about numbers from the same set, or elements from the same set. Okay. And then lastly, these are just exercises in saying, well, what would have to be true? So here, for example, for these two matrices to be equal, negative 2x would have to equal 8. So we have a little equation. Negative 2x equals negative 8, and x equals 4. Okay? And over here, similarly, 5x plus 2 would have to be 12. So 5x plus 2 equals 12, 5x equals 10, x equals 2. Okay, so that would tell us that this should be a 10, I guess, because x is 2. Okay, so that's how we solve matrix equations. So here's the things you should be able to do. You know what a matrix is? You know how to describe the dimensions of a matrix. You know how to determine when two matrices are equal. You know how to add matrices, and you know how to perform scalar multiplication. Okay, and we're going to build on that. And I know at this point this seems kind of silly, but that's how we'll go. Okay, and we're going to use this for different things, so we'll see usefulness of it as we go along. Thank you for listening, and please give me 4 stars on Netflix.